Here's the thing about buildings. Even with the best design and planning, they almost never perform as intended. The gap is real and it's addressable. Every episode, we get into the building science with the people closing it. This is Building Performance Unlocked.
Hello, everyone. Welcome to the Building Performance Unlocked podcast from AeroSeal. This is our third episode. I'm Bill Shadid, and I'm the host and moderator for this podcast series. We're really glad you're here, and we've got a great episode for you today. If you've watched or listened to any or all of our earlier episodes, welcome back. And we hope that all of you will view or listen to future episodes as well. Today's episode is titled The Retrofit Imperative: How Existing Buildings Become High Performers. Most of the buildings that we'll be using decades from now are actually already being used today, meaning they're already existing. And that makes existing buildings, not necessarily new construction, the biggest opportunity for improving building performance across all of our cities, states, and countries. But the word retrofit, when it comes to buildings, has the perception of being overly expensive and complicated, with building occupants either living or working in a construction zone. So today what we're going to do is talk about what makes projects simpler or what makes them more complicated. We're also going to identify simple things that can be done with a good ROI. And we'll look at scopes of work holistically for a building overall for retrofit projects versus individual tactics. And we're going to keep it practical. So I'd like to welcome our guest speaker today, Kelly Westby. Kelly is the Managing Director of Building Operations, Decarbonization, and Efficiency at Stephen Winters Associates. We've enjoyed working together on projects in the past, and I'm confident you're going to find her insights and observation and knowledge really, really helpful for you. Kelly, why don't you go ahead and give a brief overview of your background for our audience?
Yeah, absolutely. Well, thanks for having me on the podcast, of course. So I am an engineer. I've been at Stephen Winter Associates for about 15 years now, and we work with building owners, policymakers, program implementers to try to figure out what's going on in buildings, figure out what the best solutions are to solve those problems, and then hope to scale up those solutions by either training building operators, changing policy, or implementing better programs. My background is in the commissioning space, so a lot of time in the field, also working on deep energy retrofits, helping owners implement practical measures. And I'm also very involved with ASHRAE. I'm the New York City Decarbonization Committee Chair.
Cool. Thanks, Kelly. Well, we share a bunch of things in common, including a passion about carbon. So happy to be here. And with that said, Kelly, I'm going to go ahead and get us going on our questions for today, okay?
I love it.
So first question, why do you think the existing building stock versus new construction is the real opportunity? And I'm wondering if in your answer, you could tie this to both cost and benefits, both dollar cost, as well as what we might say is carbon cost. You know, maybe it's more embodied because we're reusing existing building, but operational as well. And then also we'll talk a little bit on benefits to both building owners and building occupants.
Sure, absolutely. That's a lot to cover, but I'll try to keep it fast here. So, I mean, look, a blank space and a blank slate is really nice to start from. New construction, very nice. Existing buildings, a little bit harder. But according to the World Economic Forum, around 80% of the buildings that we have today will still exist in 2050. So the problems are already out there, and it's essential that if we're thinking about combating climate change, that we retrofit these existing buildings for energy efficiency and carbon emissions. We can't, unfortunately, just net zero construct our way out of this issue that we have. So I also want to touch on what you said about embodied carbon. So people say the most sustainable building is the one that already exists. I would say it's probably not always a slam dunk. There is a study by the Preservation Green Lab that looks at life cycle carbon savings. And it does show that there's about 4 to 46% of a life cycle carbon emission savings from adaptive reuse versus new construction when they're built to similar performance levels. I think it's important to say that the similar performance levels component, because when we're talking about projects like adaptive reuse, you might have historical preservation aspects to the building that allow you off the hook in terms of your energy efficiency requirements. And if you take advantage of that opportunity to get let off the hook, then you might build a building that's actually not really saving in terms of life cycle carbon. I also think it's really important, and we'll hopefully get into this discussion a little bit later, but If we think about the quality of life for folks, we worked on a project that was adaptive reuse, and it was going to house seniors. And so thermal comfort was even more critical than it might otherwise be in this case. And we actually had to, as Stephen Winter Associates, come in and sit down with the folks at the Historic Preservation Department, sit down with the developers and get everyone together to convince them that leaving the walls without insulation was not a long-term strategy for housing seniors. And so I think there's so much opportunity in these buildings, but in the existing building world, it is still true that every building is a snowflake, and we need to be thoughtful on a case-by-case basis.
Let me throw this out there too. Say versus 20 years ago, maybe even 15 years ago, it seems like today we have newer technologies that have come out in the last 15, 20 years that enable us to take our existing building stock and actually make them into high performance buildings versus say 20 years ago when maybe we weren't able to do that, given some of the newer things we can do with buildings today, whether that's, things we can do to the building envelope, whether it's HVAC, whether it's lighting, a number of things. Would you agree with that?
That's interesting. That's probably right. I think technology continues to evolve and we continue to have more available at our fingertips. I also think, also regulations are changing. So the constraints that building owners are under, both from a carrot side, so incentivizing adaptive reuse, and a stick side, so requiring carbon emission reductions. So the landscape is evolving in a lot of different ways, but technology certainly is a key component. My background being in commissioning, I think oftentimes technology gets put in as the solution, but it's a part of the solution. I think buildings operate at the space between the technology and the people living in them and the just built environment itself.
Yep, got it. What would you say some of the benefits to building owners are of doing a retrofit project versus new construction?
This is a great question. So I think the embodied carbon is an aspect of it. It's a wide range and it depends on the project, but I think that's important. I do often hear that it's cost effective to do adaptive reuse versus new construction, but what we see is that that's really case dependent. We have a large project in Manhattan that was not able to make adaptive reuse pencil and have developed a plan to tear it down and build new. For them, actually, the community is resisting, so I don't know what will actually happen with that particular project. But we are seeing developers find that some of these things aren't penciling. There's a specific type of layout that you might need that might be applicable when you need to cut out portions of the building to allow light to flow in. If you're doing office to resi, there's a lot of constraints around that. And so there's probably a ton of other content. We can include that in your show notes. Some of the content around the zoning laws that have changed that maybe allow a little bit more of this adaptive reuse development. Still, what we're seeing from clients, what we're hearing from developers is that each project needs to be kind of taken on a case-by-case basis to make sure that it can pencil individually with the specific constraints of that layout.
What type of benefits would you say a retrofit project can deliver for the building occupants, whether it's a workspace or a living space?
There's a wide range of benefits that can come from these types of retrofits. So it really depends. I mean, there's a broad spectrum. We could do a lighting retrofit. We could do an HVAC retrofit. So we could probably get into a bunch of different specifics. But let's take lighting, for example. Lighting has a huge impact on how people feel in the space. And a retrofit could improve the way people feel or not. Sometimes I think we've all tried those LED lights that have the wrong color temperature and turn your space blue. And nobody wants to feel like they're in a hospital all the time. Even people in a hospital. Even hospitals don't want to feel like they're a hospital.
Right.
So being careful about what are your goals for the retrofit and what impacts might it have on the building, and how can we make sure to carefully design and implement the solution so that it has the results that you want. So lighting can make improvements. HVAC can improve comfort and reduce energy at the same time. Window retrofits can actually improve noise. And it doesn't even have to be triple pane. When you switch from double hung to casement, you can significantly improve the amount of noise that comes from the street. And we've seen that across the board. So it really depends on the retrofit. But I think to speak to your comment of what can improve, Well, we have to be clear about what we want from the beginning so that we integrate that into the solution.
Indoor air quality can improve because of HVAC improvement as well, right?
Absolutely. I think indoor air quality is honestly a tough thing sometimes because it's very hard to measure consistently across an entire building. But of course, we've worked together on ventilation retrofits. If your ventilation system isn't working, which is true of like 90% of multifamily buildings in New York, and I say that a little loosely, that number does not tie to a study, but in my experience, almost none of these ventilation systems are working. And so if it's not working, then you're not getting airflow from the right spaces and you're not exhausting it properly outside. So if you retrofit your ventilation system and you add a new fan on the roof, because it's a more energy efficient fan, you actually improve indoor air quality 0%, none at all. But if you fix the problem, which is most often the leaky shaft, if you fix that problem, which is the distribution, which is honestly where we often see the problems are, then you can improve indoor air quality. So again, we see that same thing of like, we can make improvements. There's opportunity there. If a system is broken and you fix it, you will probably make improvements. But we have to be clear about what are the challenges and that the retrofit is actually solving those problems rather than just putting a Band-Aid on.
Makes a lot of sense. So when we think about the spectrum of retrofit projects, where do they genuinely get hard? And where are the more accessible wins, do you think?
So I think there's a lot of opportunity for improvement in the control strategy, in the setbacks, anything that you can do at the central BMS, if you have one. That's not every building, right? But anything that you can do to trim around the edges that no one will notice is obviously a clear win. Someone needs to go in, retrocommission. So go in, test the systems, optimize for the current facilities requirements, and you can generally get improvements. And there's a few studies around what improvements you can make 10% on a typical retrocommissioning study. And it'll depend on the type of building. It depends on the pre-retrofit energy use. In DC, we're kicking off a building retuning program where we're training folks on basically retrocommissioning, retuning the buildings. I'm hearing a lot more clients ask about that now. On the flip side of that, I think for a long time, we were very focused on heat pumps and what we could do to completely electrify every building all at once right away. It is a big challenge for a lot of buildings to undergo a complete electrification retrofit. First of all, a lot of buildings are actually well on their way. For example, in New York, buildings are well on their way to comply with the local law 97 requirements. I know a study from Urban Green Council that talked about, I think 40% are already in compliance, multifamily buildings are already in compliance. Another 25% need to save less than 20%. So they don't need a full electrification retrofit to eliminate all of their fines. And electricity is expensive and getting more so. And so it also introduces the complexity of operational costs, which we need to be paying attention to as we evolve. Now, that doesn't mean that electrification is not going to make sense in any case, but there's a wide spectrum of types of retrofits, and some are going to not displace tenants, not be even seen or noticed, to the other end of like a full central plant renovation. I think in between is something like a distribution upgrade, where the AeroSeal and Clean Seal and Balance example. So we are going to disturb tenants. We're getting into their space. We need to access their units more than once. Same thing with steam optimization. You can get reliably 15 to 30% savings with fixing the distribution system for your steam building, but you do need to get into every apartment. You do need to get in every time, but you can get a reasonable, simple payback on those projects.
Would you say, we talked a little bit about lighting, probably a lot more about HVAC. What about building envelope? Do you see retrofit projects that are trying to improve the building envelope? I mean, I think that is an example where there are a couple newer technologies that make, whether it's adding thermal insulation or sealing air leakage, that are easier to do today than it was 15 years ago, say 20 years ago.
Yeah, absolutely. So yes, on the envelope side, we are seeing more retrofits there. Now, envelope is a big spectrum. spectrum. So I mentioned that project that had new casement windows and significantly improved noise. That was a project that also did package terminal heat pumps. So they did a window and package terminal heat pump. So there was a lot of energy and carbon savings overall for the project. It's not clear what was attributable to the window, but reducing the draftiness did improve the comfort, which helped when switching to electrification. So that's one example. There's also a few projects that have done deep energy retrofits, so maybe saving more like 50% overall energy savings. And actually, we did a panel, and I like to think of it as electrification or deep energy retrofits 3 ways. And each one project did an overcladding. So they had a brick wall with very minimal insulation, and they used Dextol panels to overclad. And they were able to run some of the new electrical and condensate lines and things like that in the cavity between the wall and the new exterior wall.
Yep.
Obviously, that's a specialty case because they did have space to add, I forget what the number is, but somewhere between 8 and 12 inches to the outside, something along those lines. So that's one option. Another option is recladding. So we actually have a project. I don't know how replicable this is. We'll see if anyone takes it on, but we have a project that is part of NYSERDA's Empire Building Challenge. And they had, this was actually pretty incredible, residents in place, so fully occupied retrofit. They put in a temporary wall from the inside, tore off the exterior wall, and then put in a new Dextol panel, actually. We're not sponsored by them or anything, but that's what it was. And then we have another project that was an EnerFit project, and they insulated from the inside. Now, these projects with these major envelope upgrades, this is all in, but these projects are costing hundreds of thousands of dollars per apartment. As an example, if you looked at just a window and a package terminal heat pump, that's on the order of $30,000 to $50,000 on an apartment. So you're talking about orders of magnitude different style of retrofit. Now, not all of that was the envelope. These were deep energy retrofits, so cabinetry isn't included in that number. But that's a very different style. So not only when a building is at a remortgage situation or at some other capital event, are they going to undergo that kind of deep energy retrofit. But there's always air sealing that can be done. If you have a through wall unit, if you have windows that you can seal around, it depends on the building type, but sometimes some sort of roof insulation. If you're re-roofing at that point, that might be an opportunity. So the takeaway here is there's probably something to do about envelope. Envelope improvements do improve comfort and do help in terms of resiliency, but it's not always going to be financially achievable in every case.
Sure. So I'm curious, Kelly. We've talked about a number of things, some of which are more complex, some of which but what might be a couple, say, more simple, financially accessible retrofit types of strategies or tactics that a building owner could do to gain improvement on their building?
It really depends on where you start, to be honest. I think, across New York City, we have local law 87. There are certain requirements. We have local law 88. There are certain requirements for lighting controls. So a lot of buildings have already done the lighting upgrades, have already done lighting controls. A lot of buildings have already insulated their steam distribution piping, at least whatever's exposed. A lot of buildings have already done weather stripping. But if these are the kinds of things that you haven't done yet, and especially if your building is less than 25,000 square feet, maybe these larger building laws don't apply to you. These are some easy early wins to just not waste. I think the energy management system. So if you do have a steam system that has no indoor temperature feedback, that could be something to consider. There's a few different options in terms of providers. If your building does have a central building management system, maybe it's more of a medium size or large building, optimization and retrocommissioning can be a really great place to start. So it is going to depend on the building. And I think starting with a trusted consultant and advisor, again, this will be dependent too. Some larger organizations have an internal energy team that knows exactly what's going on in each of their buildings. They already have an energy advisor. Some buildings are just now understanding the laws and what's applicable to them. And so having someone who understands building systems and can provide recommendations based on the current conditions of that particular building.
You hit on this a little bit earlier, but when you brought up a good point, which was knowing what the goals are for your retrofit project before you start. And I want to tie that back to a question about kind of maybe baggage that exists out there in the world, that when people hear about retrofit projects, and they might immediately have some baggage that comes into their mind. And by baggage, I mean, oh my gosh, this could be a gut job. It's going to be real complicated. The budget's going to get blown. I got people, whether they're workers or residents, are they going to be living in a construction zone, and for how long, right? So I'm curious, one, how much of that reputation is earned and how much is myth? And maybe does that tie back to having clearly defined goals and objectives, and then managing, both your design, what you're going to actually do to achieve those goals, and how does that all tie together in terms of dispelling some of those, myths out there? Every retrofit project is going to have a blown budget and just be messy and complicated.
Well, I think the reputation is very valid, I would say. We supported a study back in 2010 to look at post-retrofit performance across a variety of energy efficiency retrofits. This one was specifically focused on affordable multifamily across New York State. The realization rate that we found across all of these projects was 61%. The realization rate is the actual energy savings divided by the modeled energy savings. So that means that for every 100 BTU that was promised, only 61 were saved. Right. So we are seeing that sometimes things are being overpromised and underdelivered. One thing I've also been hearing from the market is that sometimes energy audits are saying one thing in terms of cost, but when they get cost back from the contractors, they're hearing something else. And to be honest, I was even talking to NYSERDA the other day, and they were saying the cost studies that they've been doing quickly become out of date because costs are changing so rapidly now. And so it makes sense that any cost information you have, 6 months and maybe 12 months until you actually get the contractor's feedback, a lot's going to change in that time. So I think we have an opportunity to be connecting more as a market to better understand what's going on. We are showcasing that these deep energy retrofits are possible, like you mentioned, but they are expensive, like you mentioned. So $300,000 an apartment isn't necessarily affordable if it's not a huge revitalization project.
Right.
But I think that, to your point, we need to align stakeholders on what the goals are and what the priorities are for the building. Do we want to eliminate fines in 2040? Local law 97 fines in 2040. Do we want to comply with DC BEPS? Do we want to reach some sort of net zero global target that the organization has? Or is that not it at all? And we want to reduce some energy use? Or the windows are really drafty and people just want a comfort upgrade. And so I think aligning on what the problems are and what we're trying to solve, and be really clear about documenting that from the beginning. Because the other thing is, some of these retrofits might actually uncover other issues that your occupants, your tenants, whoever, students, depending on the type of building, but they'll now see because those things are exposed. So for example, with a steam distribution upgrade, if you have back pitch piping, you can find that the retrofit actually uncovers the water or the hammer that you have in the system. And so if we don't document the conditions in the beginning and understand what the outcomes could be, I think that can result in unhappy customers. Another example is with ventilation. If you do a ventilation retrofit, and the purpose of that retrofit is to balance so that everybody gets the same amount of airflow in a multifamily building. So the top floor isn't getting like 350 CFM, like all this kind of air, and the bottom floor gets nothing, right? And so you have mold in the bottom and noise at the top.
Right.
Okay, well, yeah, we want to balance it. But does the top guy really like having steamy showers and getting that space cleared in like 35 seconds? Maybe. And when you take that away from him because you're distributing it evenly, like, people like equity until it comes to their own house, and then they want better than everyone else, right? So I think being realistic about what the outcomes will be from the beginning so that people know what to expect. I think that's an important part of it. So it's not necessarily that the retrofit is failing, but that we were failing to let people know what to expect from the retrofit.
Yeah. No, that makes perfect sense. Let's talk a little bit about comfort and health. And so that can be harder to kind of maybe define quantitatively sometimes on a spreadsheet, but it's what people feel every day. And, I always like to say that we as building professionals, whether you are a consulting mechanical engineer and I'm still working as an architect, or now you're working as an energy consultant and I'm working with sustainable building products, we're still all responsible, I think, for delivering better buildings for the human beings that are inside them. So that's a lot of times around comfort and health, meaning maybe indoor air quality. I'm wondering, like the upgrades that we've been talking about, how would you say they are changing the experience of living, say, in an apartment building, for example? Or maybe if you could talk a bit about temperature swings and how does this impact that, drafty apartments and such, and indoor air quality as well, in terms of whether that's odors or whether it's contaminants in the air.
Yeah, absolutely. So taking us back to the different types of retrofits.
Huh?
So for steam optimization, the idea is that when I create steam in the boiler sends that steam out to the entire system, ideally all at the same time, and distribute it evenly across the floors. What ends up happening instead is that the folks furthest from the boiler get their steam way, way later. They call up and complain, and then the boiler gets turned up. So let's just pump more steam. And then this is like a feedback loop that continues until everybody in their building, except for maybe that guy at the end, has open windows.
Yeah.
And we've all seen this before, we know. And frankly, the boiler and the steam distribution system was built and designed to accommodate open windows. We don't have to get into that today, but
Right.
and so these systems are overheating the entire building. Some people like to live with an open window and their shorts and t-shirt on in the middle of winter. However, most people do feel uncomfortable in 80 degrees in their apartment. So once we do a steam distribution upgrade and we even out the steam to each of the apartments, that means that everybody gets steam at the same time, at least within a reasonable amount of time. And everybody in the building should have much more even temperatures. It's really the same theory with ventilation and indoor air quality. So with ventilation, we want to see even airflow throughout the building, and we want the airflow to come from the bathroom, not from the wall cavity.
Huh?
So if we're exhausting air from the wall cavity, that doesn't actually improve my indoor air quality in my bathroom or my kitchen. But if we are ventilating from the space, now I'm improving the indoor air quality.
Right.
And I'm allowing access to proper indoor air quality to those bottom apartments that maybe had no airflow before.
Huh? Got it. Thank you. Let's go back to thinking about, again, maybe the right mix of things you can do on a project. And so we've mentioned duct and ventilation shaft sealing. That's an example of a lower disruption, good ROI measure, as we talked about on the first episode, actually, in our podcast series, that most often the companies doing this work really only need to go into the apartment units twice. And each time it's maybe for an hour, because more of the work they're doing is in the vertical shaft, right? So that can be low impact and it can be good ROI. But it's just one of many things, as we've said several times already today, that we can do on a wet retrofit project. How does an owner think about assembling the right mix of those individual things you can do to make an overall project?
Yeah, I would again go back to every building is a snowflake, but I think in
Meaning every building's different.
yeah, and every building's different. And I think the application for this ventilation upgrade is just so clear in apartment buildings. So that's kind of why we're keeping going back to multifamily. Within multifamily, the HVAC system is the bulk of the energy use. The domestic hot water is a big chunk of the rest. So those are the systems we want to be paying attention to. So ventilation, the upgrade there will help us reduce the load on the HVAC system. So that's an important measure to consider. I think we can always do low flow fixtures in the apartments. Of course, we want to be careful about how we message that to residents as well and how low we go.
Right.
Yep. But that could be an important component. I think, to me, the important mix is making sure that if you're doing a retrofit of a system, you're looking at all the components of that system together. So if you do a steam optimization and a ventilation upgrade at the same time, that would be great. But what I wouldn't want you to do is replace the boiler and replace the fan and forget the rest of those systems.
Right. Yep.
So when I think about the whole project, I think about making sure you're addressing the whole system issues. And then the next component of that is like if we're upgrading the heating system or adjusting loads, we want to make sure that the new adjustments are getting fed back to the boiler. So always considering when we're adjusting HVAC systems, some sort of internal feedback, either to the boiler or the new heat pumps or whatever. So I do think that's an important component, because if the feedback doesn't get back to the central plant to make adjustments, then those adjustments may not happen. If you fix your ventilation system, but everybody's still got their windows open, you may not be having the savings that you thought you might have. And I think another component that we've been discussing recently is if we do electrification retrofit, it is a good idea to consider a ventilation upgrade. It is a good idea to consider, is it time to replace your windows anyway? Windows don't necessarily pay back on an energy efficiency alone.
Right. Yep.
But if it's time to replace them anyway, this might be a good bundle. And oftentimes, there's two different schools of thought in terms of like bundling a bunch of measures together or doing it over time. And that decision depends on the building's access to capital. And then you get outside of my expertise in terms of engineering, but depending on your access to capital. But if you're going to do, an HVAC improvement, I really do think considering the ventilation system, considering the envelope, those are important things to think about before you just go right into HVAC.
Got it. Here's a nice broad question. So I'm sure you've seen retrofit projects that have delivered and been successful, and others that perhaps disappointed, either hopefully not holistically, but at least in part. And I'm curious from your perspective, what separates a retrofit that lives up to its promises versus one that falls short? Like, how does design and engineering play into that? How does construction play into that? How does even the choice of the strategies or tactics you're using play into that? What do you think has more impact? How do you manage that better so that you don't get disappointed and that you're actually delivering on promises?
Yeah, absolutely. So a couple of things. So one is that study that I mentioned earlier that showed that there's 61% realization rate. The other thing that it showed is that the best predictor of post-retrofit energy savings was pre-retrofit energy use. A not good statistical correlation was between modeled energy savings and actual energy savings. So statistically, you're better off just saying, does it use a lot now? Well, then it'll probably save a lot.
Yeah. Okay.
So that's one consideration. So a building has an end state depending on the systems that you end with, and that's as low as it can get. I've seen very extensive deep energy retrofits, and you get to for those that know, energy use intensity of 22 kBTU per square foot per year, which is like on par with some new construction. So that's possible, but it has to be a full gut renovation. So anyway, the higher you use now, the more you can save. That's kind of a structural element. So another thing that we saw that really was disappointing for folks. There was a big thought that if we replaced boilers, that we would save energy. And this happened both with old steam boilers and with moving to condensing boilers for more of a hydronic distribution situation. In both cases, when we didn't touch the distribution system, again, the savings were not realized. And it was very disappointing because it's expensive to do a boiler replacement.
Right.
But people were excited about the boiler replacement because you don't have to bother any tenants. So it felt like a win of a project. And I think sometimes when we take the easy way out, when we think, oh, okay, well, we don't want to bother the tenants, but we want to do energy saving, so let's just do a portion of this, you're not going to get it. You need to do the full thing.
Yep.
So that's where we've seen some disappointments. I think where we've seen some successes, like you said, when we get alignment up front, when it's a high energy user, when that system has been identified as a high energy user. So I think your case study of 150 is a great example of this. The building had some high energy bills. They were going to be facing some fines ultimately. And they were able to identify this issue with the ventilation system.
Yep.
They did a full comprehensive retrofit and they were able to see the savings. I think the other key element that actually a lot of people don't talk about in my experience, I think every great project has a project champion.
Right, within the building owners organization?
Within the building owners, or it could be someone else, but it's usually within the building owners. On that side, you had a very committed member of the board who was very involved throughout the process, very involved in garnering interest from the beginning, in understanding and accessing capital, in moving the project forward. The same thing happened on another retrofit I know of, where it was a co-op building, which are often challenging, honestly, to get retrofit projects through because you have to get a bunch of disparate individuals who aren't necessarily building technologists together to agree on something for their own home. It's a big challenge. This particular project was a huge infrastructure upgrade. The infrastructure was somewhat falling apart, but they had a champion on the board who really was seeing the project through to completion. So I'd love to say, like, pick the perfect energy consultant. And I do think your mix of technical consultants is critical, but it is even more critical to understand that your building is ready and to have the person who's going to push through barriers, because there will be barriers that come up.
And that person you said to be a champion of the project. And if it's not somebody that's, say, an employee of the owner, say the owner's organization, or a resident in like the example you mentioned, it could be an owner's rep that the owner retains as a consultant, right?
Absolutely. Could be someone from the project management team, but they have to have both actual authority and there's got to be a word for this, but like authority in that people actually listen to them. Because some people have like stated authority, but they don't really.
Right.
Especially in a co-op situation.
Yep. Got it. Cool. Okay. So let's talk a little bit about building performance standards. And, I'm thinking like Local Law 97 or BERDO, where they're putting carbon and penalties on the table. How did some of the practical improvements that we've talked about, how do they keep owners ahead of compliance? And then for someone who's been putting it off because of the baggage that they perceive for retrofit projects, what's the first kind of low regret move that makes the internal case look attractive to them? But how do those, some of the practical improvements that people can do, how do they keep them ahead of compliance?
Yeah, I think that's a great question. I think when Local Law 97 first came out, it was 2019, the world was a different place. So maybe lots of different things, but I think everybody, New York Times included, said we needed to electrify everything overnight. And a bunch of people went out and got feasibility studies for electrification. They saw the price tag and they said, no, thank you, we'll wait. And then everybody waited. And all of these retrofit projects that were supposed to be materializing didn't. Same thing happened in BERDO. I think DC is honestly in an even worse place with their building energy performance standard because of the political back and forth that's happening that could be pushing back some future deadlines. So people are unclear about how it's really going to be implemented in DC, and that's been even harder. In New York, I think there's been a lot of clarity that Local Law 97 is real and happening. But Local Law 97, even when it first came out, the thresholds were actually a little bit more challenging. Fewer buildings were meeting the threshold. So it's going to be 20% of buildings were going to have to do something to actually comply by 2025. By the end, it was only 7% of buildings or something like that.
Okay.
So the first round was really about submitting your building. Like, you just had to comply by submitting your building to DOB. If you were one of that small percentage of buildings that were over the limits, at least convince DOB that you were doing something. That's basically where we're at. Now in 2030, it gets a little harder. I think about 40% of buildings are compliant, but a lot of buildings will have to do something. And so I think as it's ratcheting down, we're starting to see people come out of the woodwork. So what I want people to understand is that they don't have to electrify everything today, but you need to be developing a plan. Your systems may not be decrepit, or they might be. If you're replacing something today, you need to be understanding that you should be installing a system that's let's say 2040 compliant, right? We don't need to get all the way there. You don't need to be 100% electric, but if you are doing replacements, how are you getting in line with a long-term strategy? So what we've been seeing is you do need someone to kind of meet the building where it's at, see what the constraints are on that particular building, see what the opportunities are on that particular building, see what the thresholds are over time for that particular building, whether it's New York, DC, Boston, and align a long-term pathway that aligns both on the technical side with feasible options, whether it be a clean seal and balance scope, whether it be a phased electrification scope, and align that with the capital access that the building has and what the capital events are over the next 15, 20, 30 years. So at this point, the urgency is really around creating that long-term plan.
Okay. Last question I have for you is, I'm just curious, do you see much of, say, higher performance standards being used in retrofit projects, whether that's net zero, whether it's LEED certification? Passive house is getting used on more and more larger types of buildings, both retrofit and new construction, whether that's, FIAS or whether that's Passive House Institute. Do you see that growing in use on retrofit projects, or are we maybe not quite there yet?
We worked on one of the largest EnerFit projects, and it is a very big challenge, but I do think folks are interested in committing to that. We are seeing significant savings from that. I think not every building is going to go after the specific certification, but as we learn lessons from the projects that do, we can understand what the best practices are, what the minimum performance standards are to get the savings, and what maybe can be like backed off a little bit. So I think, certain difficulties have in the new construction space around passive house. There were a lot of challenges in the beginning of trying to find ERVs that were compliant with this specific standard, right? So as we started implementing the standards of passive house, we could see where the challenges were and either make adjustments. FIAS created its own standard. Right. Of course, there's competition in the standards world as well. So I do see that coming about. I mean, passive house is being pushed huge in Boston because of the regulation. LEED is huge in other areas because of regulation. So I think once it's tied to regulation, that really pushes the standard. And I think the framework is really helpful for people in terms of the list of what you have to do and setting certain thresholds. But I think you can have a really amazing retrofit. This project that I talked about that got to a EUI of 22. I don't think that went through any passive house standard or anything like that, but they did new envelope improvements. They did window improvements. They did a ground source heat pump. That was the key, to be honest. And they could do that because if this particular project was upstate, and so there was a little bit of easier economics on the ground source side. So I think we will see a mix of just high performance retrofits that are not certified. I think we will see more certified retrofits. I hope we need to see more retrofits in general. So I think we'll have a little more of everything.
Well, I think that's all the questions I had for you today. Before we say goodbye, though, I'd love to know if you have any parting thoughts to share with our audience regarding retrofits and how existing buildings become high performers.
Yeah, I think the takeaway is there's something that your building can do, or the building that you're working on. There are always opportunities. It doesn't have to be a deep energy retrofit tomorrow.
Yep.
It doesn't have to be all electric tomorrow. Start with setting your goals. Start with setting your timeline. Understand your access to capital. Create a long-term plan. One of the things that I've spoke with Vornado about is actually just doing the planning up front and understanding when a system fails, what they will replace it with. Because at that point, it's an emergency, right? So you don't know when the system's going to fail, but if you have the backup plan already stated in advance, it can still be difficult, frankly, to do anything better in an emergency situation, but it's easier if you have a long-term plan. So I think that's the takeaway, that this is a journey and we're in it together and there's a lot of opportunity.
Great. Yep, I agree. Well, sounds real good. Well, thanks for your time today, Kelly. Greatly appreciate it.
Thank you so much.
And you bet. We appreciate you being here and sharing all the insights and knowledge you have. Thanks for the audience for listening today, and keep a lookout for our upcoming further episodes of our podcast series. And with that, we'll sign off. Thanks so much.